Hello everybody. So in a previous Blender video, we have seen the instance on points in Blender. Now in today's video, we will see another very important node and this is called distribute points in Blender. So we will spare the cube for today also and let's go to geometry node. I will merge this section because we don't really need the spreadsheet. I will select the cube and click on new and we have the group input and output. So this group input is basically whatever is our mesh initially, and output is whatever is the output after all the operations that we do in geometry nodes. So now we will start with instance on points that we already know. And what will really happen here is basically it has some instances like some objects or whatever we give in our points in the cube. So right now there is nothing. So we can add an instance like this. Let's add a cube for now. And we have some cubes, 8 cubes, because the cube had 8 points. Now, what if instead of just wanting 8 cubes at the points, we want lots of cubes in our faces? And that is the purpose of the distribute points. So what we can do is distribute points on faces. We can simply bring it and drop it here, and we have something strange over here. And the problem we are facing is because of the large scale. Simply, if we just make the scale as 0.2, what we will see is lot of cubes in the form of a bigger cube. But we don't really have the bigger cube, and that is because we are doing lots of operations, and then we have the group output, and we don't really have the group input as it is in the group output. So what we can do is, if we want the cube, we can add a join geometry. We can bring it here, and the join geometry can basically merge multiple geometries. So we do have the cube now. But I will say that it really doesn't look good. So I think this kind of setup looks much better. And in lots of sci-fi scenes, we do have lots of floating around cubes or something like that. So that could be one application of the distribute points on faces. Now there is density as well as seed. So what does the density do? If we just make it 1, we will have lot less cubes. And what is the shape of the initial object? This is not very clear right now because the density is low. It is not really forming any shapes. So if I just make the density as 20, it will add lots of cubes. So yeah, that is how it is. And also one more thing that we can do is, let's say the initial geometry is not a cube. Let's say it is a plane. I think we don't really have a plane here. So plane, no. So what we will do is we will simply add a plane here, and in our cube, let's drag the plane. So now what we will do is we will take this geometry here, and now what we see is we see some cubes over our plane. Now let's do one thing. Let's increase the value of the z to 2. And this does look like some sort of a skyscraper kind of thing. Now, all the heights of the buildings are the same. That could be one issue. And I think what we can do is so we can make the density as 10. But this could be a starting point of how we can create a city. So this is how we can take care of it. And also there is one more problem, and that is it is extending in both ways. Now, there are ways to fix this. And one simple way could be by adding a transform geometry node after our cube. Now here what we can do is we can basically set the translation of the z to something like zero point 0.5. How do I know it is 0.5? Because we have made the scale of z from 1 to 2, so this should be 0.5. So now this is our city, and we still have the issue that all the buildings are of the same height, which is generally not true. And in this case, what we can do is we can basically add another node, and this is a random value node. And we will basically add the random value to our scale, and this looks weird. And the reason is we are using a float to our scale, which is actually a vector. So basically, we are getting one random value between 0 and 1. That is what the random value does, and the seed basically changes the value every time. So if I just change it, it will change. But the problem here is that we want three values. We don't want one value. And doing that is very simple. We just have to change it to vector. Now, if I do this, there will be no issue. Still, there is issue because the x and the y values are not proper. So what I want for the x and the y is the x and the y should be, let's say, constant. So we don't want basically the length and the breadth of the building to change. What we simply want is the height of the building to change. So now this is already looking good. This is how a city looks like. What we can do is we can add more variations. So zero point 0.2 as the minimum value of the z and 2 for the max value. Now this looks like a real city. Now we can also add little bit of variations for our length and the breadth. So what we can do is from zero point 0.2 to zero point 0.3, something like this. Or maybe we can just make it smaller. So zero point 0.2 as the max value and zero point 0.1 as the minimum value. So we may have some thinner buildings. So for example, this building looks thinner and this looks more like a real city is what I will say. And let's increase the scale of the plane to something like this. And yeah, I mean to say we can add and build cities like this. So as you can see, nobody will realize that this is made in Blender, and this will look like a real city if this is having all the good materials and renders and stuff. So this is the magic of our distribute points on faces node and also the other node. So that's it for this video, folks. And I will see you soon with another very interesting Blender video. So see ya.